Hi, welcome to this lesson on trigonometry, 2D and 3D problems, part 2. Let's have a look at question 6. A block of flats is given by PR with the base R and the top of the building being P. Okay, so this is perpendicular to this floor, RQ, and we say that R and Q are in the same horizontal plane as the point S over here. SR is given as Q units. SQR is given as 120 degrees, so in this floor triangle. SRQ, which is again is in this triangle on the floor, is given as alpha. And then essentially the angle of elevation from Q to P here is theta degrees. So that's angle RQP. Okay, so I have two triangles, a right angle triangle here, PQR, and a triangle that's sitting on the horizontal floor, which is SQR. So S could be maybe an observer who's just standing and looking at the building's base there. R, Q could maybe be a bus stop, for example. It all depends on the context of the question, right? But we've simplified it down to its bare essentials, which is just triangles. Okay. So now we want to show that the height of the blocks, so this length PR, can be expressed as this long trigonometric expression. So there's both sine, cos, and tan here, so it's quite involved. And if I break this up, if I look at it carefully, the components of this expression, it tells me, it actually gives me a clue of how I should approach this problem. First of all, there's a tan theta here, okay, and that sort of makes sense because tan theta is going to look at this opposite side over this adjacent side. And this adjacent side, QR, is a shared side between the two triangles. So that tells me that QR, maybe if we find an expression for it, will end up simplifying to something like this. Now the root 3 over 3, having a sine and a cos of the same angle, this kind of makes me think that this could be a sine compound angle formulae that's been expanded out, for example. Okay, so using that information, let's go ahead and derive. So the length PR, we want to work that out. So first of all, in triangle PQR, tan of theta is opposite PR over adjacent QR. So I have an expression for PR now. It is QR times tan of theta, which is great because we've already got a tan theta that we're looking for. So if we can show that QR is exactly Q times this entire trig expression, then we're done. Okay, so in triangle SQR now, so the one that's on the floor, I note the following observations. Angle S, what is this angle? Well, I know the two other angles, so by sum of angles in triangle, it's 180 degrees minus the sum of the other two angles. So 180 minus 120 is 60 degrees, and negative times positive alpha is negative alpha. So this is 60 degrees minus alpha, and if we add those three angles, we get 180 degrees. Why did I need that? Well, look at this triangle. I have a known side Q opposite a known angle, and now I've got an angle, 60 degrees minus alpha, opposite a side that I'm interested in. So by using the sine rule, QR divided by the sine of 60 degrees minus alpha is the same as SR, which is Q units, divided by sine of 120 degrees. Okay, so therefore QR must be equal to Q times the sine of 60 degrees minus alpha all over sine of 120 degrees. Okay, so now let's try and simplify that expression. So therefore QR equals Q times, now I've got sine of A minus B. So I can use my sine compound angle formulae. That's going to be sine A 60 degrees cos B alpha. And because it's minus, we put minus. Cos 60 degrees sine alpha. And that's all divided by sine of 120. But now, for my cos diagram, where's sine of 120? It's here in the second, so it's going to be a positive value. And it's 60 degrees from the horizontal. So it's the same as sine of 60 degrees, which is a special angle we know, that is root 3 over 2. And that's promising, all right, because we see root 3's here, so hopefully that'll help us. Okay, so that's quite a complex looking expression. So what I'm going to do is I'm going to create some space here for us to continue simplifying. Okay. Okay, so we have QR equals, so when you divide by a fraction, you multiply by the reciprocal. So essentially it's going to be Q times that entire expression, sine 60 cos alpha minus cos 60 sine alpha. And we multiply by the reciprocal, so that's 2 over root 3. Okay, so that's going to be Q times sine of 60, that's root 3 over 2 by special angles, cos alpha minus cos of 60, that's half by special angles, times sine alpha, and all of that's being multiplied by 2 over root 3. Okay, so what I'm going to do is I'm going to leave the Q as it is, and I'm going to multiply this 2 over root 3 into these two expressions. So can you see these are exactly reciprocals of each other, so they'll divide each other out perfectly, and you're just left with 1 times cos alpha, minus the 2 will go divide into that 2, and you're left with 1 over root 3 sine alpha. Okay, that almost looks right, because we got the Q, we got the cos alpha, but we have 1 over root 3 sine alpha. But I can simplify that 1 over root 3 by rationalizing the denominator. Okay, so that's a very special algebraic tool that we use whenever we have surds in the denominator. So I multiply by root 3 over root 3. Okay, that's rationalizing, because this expression is equal to 1 in the brackets, so you're not changing its structure. So 1 times root 3 in the numerator, and then root 3 times root 3 is just 3. Okay, the square root 3 times itself is square root 3 all squared, and the square and the square root all cancel each other out. So this is equal to Q times cos alpha minus, I changed the 1 over root 3 into root 3 over 3 sine alpha. And that's exactly what we needed there. So therefore, we had PR equals QR times tan of theta, but QR was this entire expression here, so it's Q times tan theta times cos alpha minus root 3 over 3 sine alpha. Alright, and that's how we've successfully proven that that is the case. Okay, so now we're given some information. If SR, which is Q, is 30 meters, SRQ, so this angle alpha, is 15 degrees, and angle RQP, which is RQP theta here, if that theta is equal to 35 degrees, calculate the height PR of the buildings. So we had an expression for PR. It was Q times tan theta times cos alpha minus root 3 over 3 sine alpha. Okay, that's this expression we just derived earlier. Okay, so Q is now 30 meters, tan of theta, which is 35 degrees, times cos of angle alpha, which is 15 degrees, minus root 3 over 3 times sine of 15 degrees. And we want to correct to 1 decimal place. So let's put on our calculator. 30 times tan of 35, open brackets, cos of 15, close brackets, minus fraction root 3 over 3 times sine of 15 degrees, close brackets, and I'm left with 17.15. So if I round that off just to the one place, so let's do that, that's going to be 17.2. 17.2 meters. Okay, so that is the given height, or the approximate given height of this block of flats. Lastly, it says if each level of the flat, so you can imagine these block of flats here, and they've got levels on them. Okay, if each level, so the height of each of these levels is 2.5 meters high, estimate the number of levels in the block of flats. Well, we know the block of flats, PR, is approximately 17.2 meters. So therefore, the number of each level is going to be that 17.2 divided by that 2.5. So let's take 17.2 divided by 2.5, and you have 6.88. So that's approximately 7 blocks, I would say. Okay, not exactly 7 blocks. It could be maybe 6 blocks and a block that's a bit smaller, maybe for like the maintenance or the laundry room or something like that. Okay, so that is how we would do this type of problem. I'll see you in the next one.